first read this sentence and then read this graph. The reason I put this on here is to get you to realize that when we read, whether it's sentences or graphs, we always read from the left side to the right side. And you read the graph the same way. And that's important now because we are going to be talking about intervals of increasing or decreasing on graphs. Okay, so it's important that we know we are reading from the left side to the right side. Okay? All right, so on a given interval, if a graph rises from the left to the right, it's said to be increasing. So something like this, if you talk about a line with a positive slope, right, rising, that is a increasing interval. On the other hand, if the graph drops from the left to the right, it's said to be decreasing. Okay? So dropping, like a line with a negative slope, would be decreasing. And of course, if it's horizontal, right, we say that it is a slope of 0, right? And if it stays the same, then we say it is constant, right? Constant. Not going up, not going down. That's a bad horizontal line. Let's try that again. How about a line tool like this? Oops. Yeah. Horizontal would be constant. Okay? So those are your three possibilities, whether it's increasing, decreasing, or constant. And remember, we're going from the left to the right on a graph. Okay. So, let's clear this off here. When we look at graphs, we're needing to find these extrema points. That's what they're referred to. Extrema points. So that's basically minimums and maximums. Okay, every graph should have some of those. If not, it's just constant. All right, so in the case of this parabola that has a maximum point at -1,5, we would say that it is, let's get rid of my picture here. Let's say that it is increasing, right? Because remember, we're reading the graph from the left side to the right side. So if you're walking along the path of this parabola, you are increasing in height until you get to this point here. Okay? So the increasing interval is from -infinity to -1 on the x-axis. All right? That is the interval part of the graph that is increasing for this parabola. Once we hit that high point, it starts decreasing. So it is a decreasing interval from -1 to +infinity. And when we're talking about these intervals, make sure you're using parentheses as our values, our ending values here, because we're not talking about what's happening at that actual location, because nothing is really happening, it's just a point. But across the interval from -infinity to -1, it is increasing. And then from -1 to +infinity, it is decreasing. And this point here is referred to as a maximum. All right. The next graph we have is an absolute value function. And you can see that from the left to the right side, it is decreasing until you hit the bottom point of the vertex here. All right, so decreasing on the interval from -infinity to +2. And then from +2 to +infinity, it's going to start increasing again. Okay, so all we're doing is we're naming the intervals where it's going up and down on a graph, increasing and decreasing intervals. One thing I didn't mention is this point right here. That is a minimum value for this absolute value function. All right, one more. Maybe. my computer's lagging here. If you can hear me, stay with me. Okay, got it working again here. This last example is a horizontal line. You can tell that it is a single value. There is no x in this equation here. It's just, equal to 4. Horizontal, constant, right? Constant interval from negative infinity all the way to positive infinity along the x-axis, right? We're naming the x values. This interval for all these intervals are the x values that it is happening at. Okay? All right. Here's another example here. We have a relative maximum point. We have a relative minimum point or two. And so let's name the intervals. This first interval right here is going to be from negative infinity to positive 2. And then this interval is positive 2 to 5. It's increasing, whereas this first one was decreasing. All right? And then from here to here, it is decreasing again from 5 to 6. Let's go ahead and make a list, shall we? 2, 5, 6. Let's say, let's put these points back here. 2, 5, and 6. All right? So increasing from, where is it increasing from? From 2 to 5, as well as it's increasing from 6 to infinity. Okay, just making a list here. It is decreasing on the intervals negative infinity to 2, and it looks like it's also decreasing from 5 to 6. Constant anywhere? No, it's not. There is no interval where this thing is constant. All right. Another example. Let's make a list again. Where is this function increasing? Down, flat, increasing right there. So this point is 3, negative 2. This point is 5, positive 2. So what is the interval that it is increasing over? It is increasing from when x is 3 to when x is 5. That is the interval of x's, 3 to 5. And that's the only interval that's going up, right? Decreasing. Decreasing. Where's the graph going down? Okay, this part's going down. So this is going to be from, on the x-axis, from negative infinity all the way to that value right there where it stops going down. So we're going to say it's negative infinity to negative 1. And then there's another interval that's going down from starting at 5 to positive infinity. All right, so from when x is 5 all the way to when x is positive infinity, the graph is decreasing. And now this example, we do have something that is a constant. Right? The interval from negative 1 on the x-axis to positive 3 on the x-axis is constant, right? Because it's horizontal. All right, and that's how we do that. All right, on this one, I have a function. I went ahead and typed it into my graphing calculator here, and it has a maximum point at 8.18. Now I'm going to go ahead and pull up my calculator here. It may take a moment to load. But I'm going to show you how to find those exact decimal values using your graphing calculator. Okay, so if we use our graphing calculator, we can hit the y equal button right here. And we can type in our equation, 36x minus 2.2x squared, and I'm just going to go ahead and hit zoom number 6 for a standard window, because I don't know what I've been doing on this calculator before, so I'm just going to make sure it's a standard window setting. And I can see that my graph has gone up, but I can't see the top, so I need to change my window settings or zoom out. I'm going to go ahead and try to zoom out to begin with and see if I can see anything. So it goes up, and then it goes back down. So all I need to do now is change my y value to a much higher value. So I'm going to change. I hit the window button. I'm going to go down here to the maximum y value. It needs to be more than 40. So let's make it at 150 because I can see my answer already. If you don't see your answer, you're just going to have to keep guessing to see how high it is. All right, so now we can see the graph, and we can find this point, right? We need the extrema point to figure out the intervals. So we're going to hit second and trace and choose a maximum that we're going to look for. You can see a blinking cursor on my screen now. I'm just going to move it a little bit. It needs to be the left boundary of my high point. So I'm going to hit enter right there. You see it dropped a line. Then I'm going to scroll over to the right side somewhere, anywhere, right side. See, it says right side. And then hit enter. And now it wants me to take a guess. So I'm going to go back and try to get on top of it and hit enter one more time. And you can see right here it says 8.18. and 147.27. Remember, we're always going to round to 2 decimal places. Okay, and so now that we have that maximum point, we can say that it is increasing from negative infinity to 8.18. This part of the x-axis is increasing, and then the rest of the x-axis is decreasing. It is decreasing from 8.18 to positive infinity. All right, so we can use our graphing calculators to help us find the minimum value or the maximum value. All right, here we go again. We'll just start from scratch. I'm going to hit my y equals button, type in my equation, 1.1 x raised to the 4th power. And then we've got minus 5.3 x raised to the 3rd power, and then 4.07. All right, plus 4.07. All right, I'm going to hit zoom and standard, number 6 again, just to kind of check it out. But these numbers right here on the screen are for us to use as window settings. These are giving us the x minimum, the x maximum, the y minimum, and the y maximum. Sometimes they give it to us, and sometimes we just have to explore on our calculator. So I'm going to hit the window button again, and I'm going to copy these settings. Not negative 9, it's supposed to be negative 3 to 9 on the x-axis, and then negative 75 to positive 100 on the y-axis. Copying these numbers into my window settings, and now I can take a look at the graph and check that out. We definitely have a minimum point, so let's find that. How do we find a minimum again? Right, we're going to hit second and trace, choose minimum. There's my blinking cursor. Is it to the left of that minimum? Yes, it is. Go ahead and hit enter. So now we're going to scroll it to the right, anywhere at the right, and hit enter again. And then we'll go back to get on top of it and take a guess, enter. And the minimum value is 3.61. Let's see, 3.61 comma, let's bring that calculator back up, negative 58.45. Negative 58.45, right? That's the minimum point. I'm going to go ahead and label it minimum. And then we had, let's explore a little bit. I'm going to hit my trace button, and I'm going to scroll, because this part right here I'm curious about. Is there a little bump, or does it always, right, so I'm checking these values, these y values, and they are getting larger. And I'm going to check to see if they always keep getting larger. So, yes, right, there is no more extreme points in this general area. So a graph comes down, and it slows down, but it never gets perfectly horizontal, right? Check out these numbers here, 4.18, 4.10, 4.07, 4.07 again, but more perfectly. The other one had a decimal, and 0.66. All right, so it's never perfectly flat, so we can't say that part is constant. It is decreasing all the way down this curve until it gets to the very bottom, and then it starts going back up. So our intervals, we can say that it is decreasing from negative infinity to 3.61, and then we can say it's increasing from 3.61 to positive infinity, right? We're only going to use the x value of our point, decreasing along here until it gets right about there, 3.61, and then it starts going back up. All right, so that's how we can use our graphing calculators to help us find the intervals that's increasing and decreasing. All right. Let's see, can I bring my picture back up? Maybe not. All right, I'm gonna have you stuck without a picture. This one says, Jenna's Restaurant Supply Store has 20 feet of dividers with which to set off a rectangular area for the storage of overstock. If a corner of the store is used for storage area, find the dimensions to maximize the floor area. All right. So here we have, we can see a picture here, kind of have a rectangle, and I hope we all remember how to find the area of a rectangle. It's just length times width, right? But they've set it up. They're going to put some of the dividers here, so that's x. They're going to put the rest of it on this side, which is just 20 minus x, and all we have to do is multiply those to get the area. Okay, so if I distribute, I'll get 20x minus x squared. Okay, think about what that looks like if we were to graph it. That is a parabola, right? A parabola with a negative x squared is going to have a maximum point somewhere. Okay, so let's go ahead and type this into our graphing calculator. We're going to type in 20x minus x squared. I'm going to go ahead and hit zoom 6 to go back to a standard window setting, zoom 6. All right, so what happens? We see it go up, but not back down. Let's go ahead and zoom out a little bit and see what we can see. All right, I can see where it comes back down now, but I need to change it to a higher maximum y value. So 40 is not going to do it. Let's try 100. Let's see if that works. Oh, barely enough. I can see the highest point there. So where is that high point? Let's go ahead and find it, right? Second trace, maximum value of this curve. There's my blinking cursor. I can barely see it. I'm going to scroll it and make sure it's on the left side and hit enter. Then I'm going to scroll it to the right side over here somewhere and hit enter. And now I'm going to try to take a guess and get right on top of it and hit enter. And it gives me the ordered pair 10, 100. The ordered pair is 10, 100. So what does that mean? That means the x value is 10 and the y value, which is the area, right? Not the other coordinate. Well, it is the other coordinate. It's x and y. It's not the other dimension. That's what I meant to say. If this side is 10, then what is this side? Well, 20 minus 10 is also 10. So we have a square, a 10 by 10 square, which a 10 by 10 square does have an area of 100 square units. So what are the dimensions to maximize the floor area? 10 feet by 10 feet. 10 feet by 10 feet. Okay? Alrighty, let's see what we got next. Hey, that's the last one. That is section 2.1. Y'all have fun.